Alright, in this section we're dealing with what's called the chain rule. So if you're taking the derivative of a function within a function, f of g of x, or f composite g of x, you take the derivative of the outside function and you leave the inside function alone initially, and then you follow that by multiplying it times the derivative of the inside function. Right, so if you're taking the derivative of f of g of x, it's f prime of g of x times g prime of x. So if you're taking the derivative of sine 3x squared, your f is sine x and your g is 3x squared. And so what's the derivative? The derivative is cosine 3x squared times the derivative of 3x squared, so it'd be cosine 3x squared times 6x. All right. Now, some people make some mistakes here when they take let's write down what the first derivative actually is. The derivative is cosine of 3x squared times 6x. Now, sometimes people, when they take the derivative, they take both derivatives at the same time, the derivative of the 3x squared and the derivative of sine. No. You take the derivative just the outside, leaving the inside alone, and then you follow that with the derivative of the inside. Sometimes you mistakenly identify the inside input of the outside function, and so you might say cosine x times sine x or cos 6x 6x. No. Sometimes people forget to take the derivative of the inside function. Don't forget to do that. Another common mistake is people don't know when to stop taking derivatives. They take the derivative of sine, they get cosine, they leave the inside alone. Then they take the derivative of what's inside, and they get 6x. And then for some reason they think they have to take the derivative of that as well. No. No, you don't do that. You just take the outside derivative, leave the inside guy alone, and then follow with the derivative of the inside. Right? So if you got sine of x squared, you're going to take the derivative of sine and get cosine, and you still have the inside function untouched, followed by the derivative of the inside function, 2x. Now what if you got sine squared x, which is really sine of x quantity squared? So your outside function is x squared. Your inside function is sine x. So your outside function for x squared is just 2 times the function itself, or 2 times sine. And the inside function's derivative is cosine. And so sine of x squared is 2 sine of x to the first times the derivative of sine, which is cosine. All right? And so when you're using the power rule with the chain rule, when you're taking the derivative of some complex function inside here, you still can bring the exponent up front and subtract 1, but you got to follow with the derivative of the inside function. That's if the inside function is a complex function, if it's a composite function. Alright, so find y prime if y equals this. So you bring the 100 out front and subtract 1. Okay? And then you follow with what's the derivative of what's inside, which is just 3x squared. So again, bring the 100 out front, subtract 1, and leave this guy alone. Then follow with the derivative of the inside function. Now sometimes you can think of it as taking your hand and covering up the inside function and take the derivative of the outside function, which is 100, this guy to the 99, and then follow with the derivative of what you just covered up, 3x squared. Alright, now this one, you can write this as 1/3 power, but you can bring it up top and write it as the negative 1/3 power. And so now you can use the chain rule. You can bring the negative 1/3 out front and subtract 1/3, or 1 from that, and then follow with the derivative of what's inside. And now this one, you can bring the 9 out front and subtract 1 and get 8, and you leave the inside function alone, but then you follow with the derivative of the inside function, and that's a quotient, so you're going to have to use the quotient rule. It's a bit complicated, but you can do it, and you multiply everything out and you get your answer. Okay, now this one, we're going to use the product rule first, and then we're going to have to use the chain rule twice. So you got the first guy times the derivative of the second, plus the second guy derivative of the first. So the first guy is untouched, second guy derivative plus the second guy derivative of the first. Well, when you take the derivative of this guy, you bring the 4 out front, and you got this guy all to the third, but you still have to take the derivative of what's inside, which is 3x squared minus 1. Now you got this guy untouched. This guy, when you take the derivative, you bring the 5 out front, subtract 1 from the exponent, you leave the inside untouched, follow it by the derivative of what's inside, which is just 2. The rest of this is just simplifying. Alright, now find the derivative for this guy. Well, you can think of it as e to the x times the derivative of the e to the sine x times the derivative of sine x. Think of the sine x as your g, your interior function, and e to the x is your original function f. So when you take the derivative of e to the sine x, you just get e to the sine x. But then you got to follow with the derivative of sine x, which is cosine x. Now sine of cosine of tangent. Well, that's the derivative of the outside times the inside untouched times the derivative of the inside. Now what's the derivative of that? Well, that's the derivative of the outside times the inside untouched times the derivative of the inside. Now what's that? Well, the derivative of tangent is secant squared, so now you finally have multiplied everything out. So you first use the chain rule. You say derivative of sine is cosine, and you leave the inside untouched, follow it by the derivative of the inside. And now for this one, you take the derivative of cosine, you get minus sine. That's untouched, followed by the derivative of what you have inside. And then the derivative inside is just secant squared. Alright, you got e to the secant 3 theta. You can think of secant 3 theta as your inside function and e to the x as your outside function. So your outside function is just going to give you e to the x or e to the secant 3 theta. You got to follow with the derivative of the inside function, secant 3 theta, which is secant tangent. And remember, when you take the derivative of secant tangent, you got to follow with the derivative of the inside function, 3 theta, which is 3. Alright. Now here they talk about the derivative of any number raised to an x power is just that times the natural log of the base b. They gave you a proof here, and if you want to look at it, you can work your way through it. That's up to you. It's your choice. But here, if you're taking the if you're given 2 to the x, what's the derivative? It's just 2 to the x times the natural log of the base 2. If you're given 5 to the x squared, your derivative is just 5 to the x squared times natural log of 5. But you also have to take the derivative of the inside function here, which is for x squared, which is 2x. And so that's what you get for that guy there. Alright, so for the questions that are similar to the WebAssign questions, this is the first one. You let u be your inside function and let f of u be the outside function, the square root of u. And the square root of u is just 1/2 u to the minus 1/2. And the square root, the derivative of the inside function is 3x squared. And so you get 1/2 times the inside function to the minus 1/2 times e to the x squared, and you get that guy there. E to the square root of x, well, the derivative of e to the x is just e to the x times the derivative of e to the x, which is 1/2 e to the negative 1/2. This guy is 50, this guy to the 49, and the inside's untouched, followed by the derivative of the inside. This one, you're going to use the product rule first. You're going to say the first times derivative of the second, plus the second times derivative of the first. And now when you take these two derivatives, you're going to use the chain rule. So this first guy is untouched. This guy is a 4 out front. This guy untouched to the third, times the derivative of what's inside, 2x minus 2. This guy's untouched. This guy is 3 times this guy to the second, times the derivative of what's inside, which is just a 4. And the rest of this is just simplifying it down. Alright, for this one, you can bring the 4 out front and subtract them from the exponent, and then follow it by the derivative of what's inside, which is just the quotient rule for that part there. That's the chain rule, right? 4, that to the third, inside's untouched, times the derivative of the inside. 5x to the 5 raised to the square root of x is 5x to the 1/2, which is 5x to the 1/2 times natural log of 5, natural log of your base, times the square root of x to the 1/2. This one is 8 times that to the 7th times the derivative of what's inside, which is your quotient rule. You got to use the quotient rule all over for that one. You can write this one to the minus 1/3, and then you can use the chain rule, bring the 1/3 out, minus 1/3 out front, and subtract 1, and then take the derivative of what's inside. For this one, e to the whatever is just e to the whatever times the derivative of what's inside, the exponent there. 41, this is really sine of x squared plus 1 squared. So when you take the derivative, you bring the 2 out front, you leave the inside alone, and you subtract 1 from the exponent. But then you have to take the derivative of what's inside, which is this guy. Now when you take that derivative, that's the chain rule again. Derivative of sine is cosine, you leave the inside untouched, times the derivative of what's inside. And that's how you get your answer there. Now this one, when you take the derivative of 10 to a power, it's just 10 to the power times ln of 10, times the derivative of your exponent. And when you reduce that down, you get this answer here. Sine cubed of cosine x squared, well, that's sine of cosine x squared, quantity cubed. So when you take the derivative, you bring the 3 out front, you leave the inside untouched, subtract 1 from the exponent. Now you got to take the derivative of the inside guy. And when you take the derivative of the inside guy, you're using the chain rule again. Derivative of sine is cosine, the inside's untouched, followed by the derivative of the inside. Now when you take the derivative of the inside, you're using the quotient rule again, and you're taking the derivative of x squared, which is 2x. And you finally get your answer there. E to the t sine of 2t is just e to the t sine of 2t times the derivative of that. Well, the derivative of that, that's the product rule. First derivative of the second plus second derivative of the first. And here you're going to use the chain rule again. So the derivative of sine is cosine with the 2t untouched, followed by the derivative of 2t. Here, derivative of t is just 1, and everything else is just multiplying it out. Here, the derivative of e to the sine of 2t is e to the sine of 2t times the derivative of sine of 2t, which is cosine 2t times the derivative of 2t, or 2. This guy's derivative is cosine of this times the derivative of e to the 2x, which is e to the 2x, times the derivative of 2. If you let your inside function be x squared, your outside function is just tangent of x, or tangent u. So the derivative of tangent is secant squared, and the derivative of x squared is 2x. So you get secant squared x squared times 2x. Here they give you f of g of x, and we know that the derivative is f prime of g times g prime, and they plug in 1 and ask you to simplify things down. Now g of f of x is g prime of f times f prime. Remember, the inside doesn't change, but you follow it with the derivative of the inside. And each one of these is the same idea. If you got fg, you got f prime g, g prime. If you got g of f, you got g prime of f, f prime. If you got g of g, you got g prime of g, g prime. And then they just plug in a 1, and then you use the numbers they give you, or you get numbers from this table as to what the slopes are at each of these given x values. You can figure out what the slopes are and know what those specific answers are. Alright, this one is this quotient raised to the 1/2, so you bring the 1/2 out front, subtract 1 from the exponent, unchanged, followed by the derivative of the inside function. Alright, this one, it's definitely the chain rule. Derivative of sine is cosine times the inside function times the derivative of the inside function. Chain rule again, derivative of cosine is minus sine, untouched inside, followed by the derivative of the inside. And you get your answer there. You can take the derivative again, which is negative 3 times the product rule. First derivative of the second plus second derivative of the first. just a lot of the product rule used over and over and over again. This one is you bring the 3 out front and you subtract 1 from the exponent and then take the derivative of what's inside. Then you can write it this way or this way, but then when you go to take the derivative, I used this one, I believe. So I had the bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared. It's a pretty complicated problem, and if you multiply by x to the 1/2, you get rid of that fraction in the numerator. Makes your answer a little simpler, but it's still a pretty tricky problem to do here. The derivative of 2 to the x is 2 to the x ln of 2. That's it. The derivative of x e to the negative x squared is the product rule. First derivative of the second plus the second derivative of the first. Well, the first is just x. The derivative of this is e to the negative 2x times the derivative of the exponent, which would be negative 2x. The second guy is untouched times the derivative of the first, which is just 1. Okay, and then this one, sine times each one of these, that's cosine of this guy times the derivative of what's inside. And derivative of what's inside, derivative of that is just 1. And derivative of that is secant squared times that times the derivative of what's inside, which is 1 plus a negative sign. And so it's using the chain rule several times.